All right, in this video, we want to solve this trig equation over here between 0 and 360 degrees. Now, generally speaking, we use our cast rule for these types of equations. But we have sine and cos in this video. So normally, we have sine and cos in the same equation. We try to manipulate it around either using trig identities or try to use sine divided by cos equals to tan. But in this case, that won't work because if I divide by cos, then I'll have 1 over cos there, and tan and 1 over cos does not work. This is a bit of a trick question. The question also gives us a hint. Use t equals to tan of theta over 2. So using that hint, we can solve this question over here. So no trig identities to manipulate it around. So what I'm going to do is I'm just going to draw a right angle triangle. I'm going to make this angle theta over 2. So if this is theta over 2, tan is just opposite over adjacent. It's just a 1 there. So opposite, adjacent, and then I can find the hypotenuse by doing my Pythagorean theorem. It's just square root of t squared plus 1. So now I know that cos of theta over 2 is adjacent over hypotenuse, and sine of theta over 2 is opposite over hypotenuse. So I have sine and cos of theta over 2, but I need to find sine and cos of just theta. So I'm using my double angle formulas. For this one, I'm going to use the cos double angle formula, which is cos 2x equals to 2 cos square x minus 1, which means that cos theta is equal to 2 cos square theta over 2 minus 1. I can replace cos of theta over 2 with this equation over here. It's going to be 2 times 1 over square root of t squared plus 1 squared minus 1. Now I can just simplify this. 1 squared is just 1. Square root and square cancel, so just t squared plus 1 on the bottom, minus 1. Multiply that in. Then I can make a common denominator here. And then just simplify the top. To finally give me 1 minus t squared over t squared plus 1. This is what cos theta simplifies to. I'll do the same for sine theta next. We know that cos 2x equals 1 minus 2 sine square x. I'm going to use this identity for sine because I have 1 sine, 1 cos, which means that cos theta equals 1 minus 2 sine square theta over 2. I'm going to replace that with this over here. So cos theta equals 1 minus, oh wait, that's not even going to give me sine theta. So you need to actually do that using the sine formula, not the cos formula. Works that out. Sine 2 theta equals 2 sine theta cos theta, which means sine theta equals 2 sine theta over 2 cos theta over 2. Then I'm just going to replace those two with these two. So 2 times t over root t squared plus 1, 1 over root t squared plus 1. Then just multiply these. 2 times t times 1 is just 2t. Root of this times root of this is just t squared plus 1. So now that I've found sine and cos theta, I just have to replace them back into my original equation over there and solve it. So I'm just replacing cos with this over here and sine with this over here. 3 times 1 minus t squared over t squared plus 1 minus 5 times 2t over t squared plus 1 equals negative 1. Now I just have to solve this as a quadratic equation. Do it on this other sheet over here. I'm going to start by just multiplying in tops. So 3 minus 3t squared minus 10t, and it has a common denominator now of t squared plus 1 because those two are identical, equals negative 1. Cross multiply that over 3 minus 3t squared minus 10t equals negative t squared minus 1. Bring it all to one side. So 2t squared, I'll move it all to the right side to make it positive. 2t squared plus 10t minus 4 equals 0. Quadratic equation here, I can divide it by 2. T squared plus 5t minus 2. This cannot be factored, so we just have to use quadratic formula over here to give us our final solution. Do this in my calculator really quick. Finally, we're just going to use our tan equation once we get our solutions for t. Tan is actually the best equation to use because that's the one given in the question. So t equals tan of theta over 2. So 0.37 equals to tan of theta over 2. Going to do the tan inverse of this. And 8.3 equals theta over 2, and then multiply my solution by 2. 40.6 degrees is my first solution, and then let's do the second solution. negative 79.5. Gotta multiply that by 2, so negative 158.9 equals theta, but negative 158 is not between 0 and 360, so this one is actually invalid. But to find the solution corresponding to this one, we know that we have a period of 360 degrees for this wave over here because it's cos plus sine in the original equation. All I have to do is add 360 degrees to this solution. And if I add 360, I'll get a solution of 201.1 degrees. So my two solutions for this question are 201.1 degrees and 40.6 degrees. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.